Today we want to look at Calloc function. The last class we did malloc function. So what is Calloc? So Calloc is what? Contiguous allocation. So if you want to dynamically allocate memory for arrays, it is better to use Calloc because Calloc will give you a well-structured and pure state from the very beginning, right? It allocates 0, initialize the values with 0 and not garbage values. So the syntax for this, you can say void pointer calloc, right? In bracket, you have size underscore t count, comma, size underscore t size, right? So this is for calloc. Malloc, you had something like this. Void pointer, malloc, then you say size underscore t size, right? So this was just the only one you had in the case of malloc. But so malloc is just simply saying, I need a memory location. Whereas calloc is saying, how many elements do you need or do you have? And what is the size of each of them? So you can see this one is much more precise than this. So that, and you can see this one has 2 parameters, while this one has just 1 parameter. This one will initialize your element to what? To 0, while this one will give you what? Garbage values. So let's write the same C program that we use for the malloc, for the calloc, and then you will understand the difference more. So here I will say include stdio.h for our print function, and then we'll say include std library.h for our malloc, calloc, and the free function. So I'll bring in my main int main function. Inside it, I'm going to declare the same pointer. So int numbers. At this point, memory has not been allocated, right? So the most important line is what we want to write now. So numbers assign. So here I'm also going to typecast. I'm going to typecast int pointer calloc. So instead of malloc, calloc. Then inside this place, same 3 elements. So here I will say 3, comma. The other one was 3 multiply. So 3, comma. Then size of int. So I'm saying 3 elements, and the size of each of them is what? Integer. So this is the most important line that illustrates this class. So I've done this. Now I'm also going to check. So I'll say if numbers equals to null, right? Go in and print f. I will say memory allocation failed /n, because I want it to now go out in a new line. Then I will say return 1 because there's an error. So I'll close this here. Okay, now I've done that. So assuming I check and numbers is not null, so it's going to skip this part. Now I want to assign value. I want to allocate values to each of the elements. because this line has created a contiguous block, right? So this is for the first element, second element, and then the third element in the heap memory, right? In the heap. So this pointer is in the stack pointing to that memory because your actions, activities will take place what? In the stack. So now I'm going to allocate. Same thing. Numbers 0, that is the first index, 10. Numbers 1, that is the second index, 20. Then numbers 2, the third index, 30. Now that is done. Though now I'm going to access my memory to pull things out and show them to the screen or point them, show them on the screen. So I'll say print F, the same thing I did there. After after Calloc, right, /n. So this will just print out on the screen after Calloc. Then below, I'm going to use my for loop here again. I'll use my for loop. Yeah, what I want to write here should be under this place. But because of the board, so I'll say for int I, because I didn't declare it outside, I'll declare and initialize. I equals to 0. Then I less than 3, right? Then I plus plus, I'll close this curly bracket. Now inside this place, I'll say print F. I want to print it out on the screen. %D. So this is a format specifier telling the CPU how it's going to interpret the 0 and 1 that it sees. So /n. Then numbers I. So accessing all the index. Then I'm going to close this, right? So this place is still not enough. I'll bring what should be here. What should be here, I'll bring it here. So I have this again to close this part. Now what do I do? After printing it out on the screen, I'll have to call my free function, free numbers, right? Then I'll set numbers to null. Assign what? Null. Then I'll say return 0. So my program is done. Then this curly bracket, I'm closing it here. So that is the end of my program. I've explained this to you in the last class, so I won't really have to waste much time in explaining. So, but the most important part of this script, which is this class, like the Calloc class, is this line. Is this line, this place, this line. That is the most important part. So the CPU will start, right? So you have your memory. Then program will come into this main. All this will have been done, and at the logical part, the machine language has been created, which is what? Binary 0 and 1. It has gone through the compiler, the assembler, the linker. The linker has gone to pull in all these guys and use them and create the memory layout. So in the heap, when the compiler gets to this place, it's telling the operating system, please, I need memory for this. So at runtime, the operating system will create memory for 3 elements. Size of each is what? 4 bytes. So 4 times 3, that is 12. So in the heap segment, so this heap, right, 12 bytes will be created. Then this is the stack. Now this is the data segment. And then this is the code segment. So this entire thing, code/text. So this, our entire program, is stored in this place, right? Now once main, the CPU access main will be copied to this stack. and then it will go in and create this pointer. So pointer will be created in the frame of stack, in the frame of main inside the stack. Then it will get to this line. Calloc will go to the kernel of the operating system to create memory in the heap. So these 12 bytes will be created in the heap. Yeah. And then the address of the first element will be stored in this pointer, which is the numbers. So the address of the first element. So you have 1, 2. So 0, 1, 2. So this address, so let's say this 100, this 4 byte, abi? So this will be 104. Then this will be 108. All right, so this 100, which is the address, for example, will be stored in numbers. And then the memory will be created. So it will check if memory has been assigned. Yes, there's no problem. Then I will come here. It will come here and allocate these values to each of that memory location. So 20 or 10 will be here, 20 will be here, and 30 will be here. So that is done. So after that, it will print out after Calloc on the screen. And then it will use my for loop to push this out on the screen. Because I still have /n, it will give it 10, 20, 30. That is how it will be printed out on the screen. Then after that, it will free the pointer, because it will be a dangling pointer that can still be used. You have to now completely eliminate it by assigning null to it. So then you return, meaning the program is completely executed. So this is how Calloc works. So let's go to code blocks. Let me demonstrate this for you to see. These are code blocks, and just like the script on the board, you can see the same script like the malloc, but I just change this to Calloc and then change the input parameters to just 2 by putting comma instead of multiplication. The same concept. So I'm just going to execute this script for you to see what the output will be. All right. Okay, so you can see after Calloc 10, 20, 30. Okay, now let me comment this out, meaning I am not going to assign values to it, and then we will run and you will see what the output will be. So I'm not assigning these values 10, 20, 30 to it. So let's see what the output will be. It should be 0. So you see the output is 0, 0, 0. That is it. That's one between Calloc, one of the differences between Calloc and malloc. So Calloc will allocate memory and then initialize that memory to what? 0. But malloc will not initialize it. So when you try to access it, you will see garbage values inside. So that is all I want to show you in this class. So till we see in the next class. Bye-bye.